So on this page from the organic notes, I just want to briefly introduce you to a couple what we call functional groups. And these are going to be organic molecules that include carbon and hydrogen, but then they also include other elements. So the one we're really going to focus on is anything where you have carbon, hydrogen, and oxygen. But you might also have some other functional groups with nitrogen, but I'm just not going to focus on them. You might know some of them from your biology background. So a few of them that we are definitely going to focus on. One is alcohol. You're going to see some interesting, what we call intermolecular forces for this. The notion, or excuse me, the symbol that you use for alcohol is OH. R just means how many carbons you have attached. So let's say I have a CH3 and then I have an O and then I have an H. And again, the oxygen has two lone pairs on it. That is called an alcohol group. So anytime you see an OH off to the side by itself, that's generally going to be what we call an alcohol. Ethers, these are the molecules that they used to use to knock you out for surgery a long, long time ago. It is any carbon molecule that has an oxygen between two carbons. And it can have as many different varieties. It doesn't have to be the same number of carbons on either side. You could see it drawn many different ways, drawn out with the complete structural formula, or what we call more of a condensed formula. So this one over here on the right is more of a structural formula. So you could see literally how many carbons, hydrogens are all attached. Here's what we call a condensed formula. That shows you kind of the same information, just in a different format. So anytime you have an oxygen between two carbons, that's called an ether. Aldehyde, this is going to be a C double bond oxygen. Again, oxygen is going to have two lone pairs. And then you have a hydrogen directly attached to that carbon. So these are called N groups because it is always going to be on the end of the molecule because of the fact it could only make one more bond. But it could be on the left or it could be on the right. It doesn't really matter where you have the actual aldehyde group, but if you see a C double bond O and that carbon has a hydrogen, that is what we call an aldehyde. Ketone, a C double bond O, but it then has two neighboring carbons at least. It could have more than that. So I could have CH3, CH2, C double bond O, CH3. That is a ketone because again the carbon is attached to an oxygen double bonded, and then you have two other carbons attached. Now carboxylic acid is going to be the other functional group. I starred the alcohol. Carboxylic acids, the one that you should know is acetic acid. That's the acid you have in vinegar. That's the vinegar smell. You're going to see this written a couple different ways. What makes something a carboxylic acid is the C has a, the carbon has a double bond oxygen, and directly attached to that carbon is another OH group. So this is not an alcohol OH group. It is a carboxylic acid. So this is what makes it a carboxylic acid. So usually what you will see for acetic acid is it's written as COOH. So that you are understanding that the carbon has two different oxygens attached and then a hydrogen attached to that oxygen. So if you see that notation, that's going to be a carboxylic acid formula that you're going to see. This is also an N group, just like the aldehyde that I just showed you. It has to be on the end of the molecule because it has already 3 bonds taken up, so it only has 1 more bond to go. And finally, an ester, C double bond OO, excuse me. And then you have a carbon group on either end of that. So again, it could be any number of carbons, but it needs to have at least 1 carbon attached to either end. So this group right in there is what makes that an ester. Now esters are found in some flavor chemistry. They are found in perfume sometimes. They do have unique smells. So that is what we call an ester. So finally, I just want to finish up our discussion on organic between what we call cyclo and benzene. Benzene is a very important molecule for organic chemistry. Its formula is C6H6. But cyclos are what we call carbon rings, but they're going to look very similar, but there is going to be a slight difference. So if I think of cyclos, I could do C5H10. Okay, and again, this is a formula of an alkene, but if it's a cyclo, that means all of the carbons are in a ring. That's what the definition of a cyclo means. So if each one of these carbons then can only have 2 hydrogens to complete the 4 bonds around it. So this has a different name than a typical 5-carbon molecule. So 5 is pent, so this is called pentane, but it's not like a straight chain, so I have to put a cyclo in front of it to call it cyclopentane to tell the reader that it's all in one circle. So cyclos have all single bonds, but benzene is quite unique. So I'm going to draw 2 different, or I'm going to draw the cyclo version essentially of C6H12 to kind of show you the difference here. So I'm going to draw 6 carbons in a ring here. They're going to have 2 hydrogens on each one of the carbons. Okay, so this is called cyclohexane, hex meaning 6. Okay, but if I draw benzene underneath it, benzene's going to look a little different. Okay, so it has bonds with all of the carbons, but it only has 6 hydrogens. So how could that work? Well, what happens is you actually have 3 double bonds through that whole structure. Okay, so I'm drawing the double bonds every other one. That's going to make each carbon only have 1 hydrogen. Okay, so this is what we call benzene. And there's many different ways you're going to see it drawn. Sometimes you will see it just as a hexagon, and then you will see the 3 double bonds in there. Another way you might see it is they put a big circle in there. Well, what does that circle mean? Well, there's going to be a word that we talk about a little bit later on. It's called resonance. Those triple bonds, those 3, triple bonds, that's wrong. 3 double bonds that are in that structure are all through that structure. That's what we call resonance. So that double bond is actually not there. It's actually in all locations, okay? So that those electrons that make that covalent bond is throughout that whole structure. So benzene does have a different structure, has different number of hydrogens, and that's going to lend itself to some very different chemistry. Okay, so I do want you to know the difference between those 2.